Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Tom Podnar, and I'm a senior cybersecurity engineer in the SEI CERT division. Today, I'm joined by my colleague, Dustin Updyke, who is also a senior cybersecurity engineer at CERT. Today, we are here to talk about our work using machine learning to make non-player characters more realistic.
Hey, Tom. Thanks for the intro.
So let's start by telling our audience about ourselves and what brought us to the SEI and the work that we do here and the coolest part of our jobs. Dustin, you go first.
So I had 20 plus years of experience in industry, and a large part of that is writing websites and web applications, mobile applications. And the sort of promise that I would be able to work on totally different things was one of the big factors in me deciding to come here. Sort of as a backstory, the first thing I did work on was a web application. But it wasn't long after I got here that we, as a team, were talking about simulating users within an exercise or training event. And some of the things that we wanted to do weren't currently supported by any software that was out there. And so that got me thinking in a space that I didn't have a lot of experience, but I was really excited to get to work in that area and think about how such a system would be designed, how it would communicate, how the different agents would communicate with one another, and what kinds of activities and decisions they would ultimately make.
Thanks, Dustin. Yeah, my background is similar from having a long history of doing network infrastructure, network applications, systems architecture, and I really wanted to get involved in cybersecurity more so than I was already in my previous lives. And so I came to CERT to do more cybersecurity. And so I was very fortunate, and you were fortunate to join our team as well. Whereas we have a good work plan where we work with cybersecurity exercise and training with the U.S. Army, and it's become really interesting work. And there's great synergies here between your talents and our team's talents in terms of developing applications that are useful for them from a cybersecurity exercise and training perspective.
Yeah, I think it's interesting how our team blends all of the different members' experiences and the background that they bring. We sort of play to all of their skill sets. And, I didn't have a traditional cybersecurity background, but a great deal of cybersecurity deals with software and building and maintaining those systems. And so I was really excited to be able to contribute in that respect.
I think that's probably one of the most interesting parts of our jobs is that we have a lot of freedom to do what we'd like to do and put our own input in and design our own parts of the process. That so far we have made our Army customers pretty happy with what we've provided to them.
I think one of the things that has kept us engaged and sort of differentiates us from other teams is our continual focus on realism, right? The Army trains as they fight, right? And we've sort of taken that same mantra and looked at how these training and exercise events are managed, how they're presented to the customer, what systems look like, how they're configured, and ultimately, what that entire, how we'll call it, enterprise class network looks like when they get on there and they start to train. And I think that you brought a lot of valuable experience in that area in working with larger enterprise level networks and the systems that live on those networks.
So, Dustin, you raise an interesting point, which is the concept of realism. And early on, when I first started working with the Army over 5 years ago, it wasn't something that was really strongly identified as something that should be included in the exercises that we did with the cyber exercises we did with the Army. And it really became clear to us after a couple years of work that realism within that exercise environment is just so critical for multiple reasons. It's critical from the idea of train as you fight. We've heard that a lot, but it's also very critical from a participant perspective, because the participants are very busy people. They're based all around the world. They're facing cyber challenges on a daily basis, 24/7, and they're very busy people. So when they're trying to gain expertise in our cyber ranges, it's very critical that they're learning skills that are applicable to their daily lives, as well as or their daily work efforts, but as well as just buy-in from a participant perspective, and that they're more likely to feel engaged and want to participate when they feel like they're immersed in an environment that it's very realistic.
It wasn't long it wasn't long before I got here that you and a couple other members of the team had published a framework called Reactor that sort of outlined the importance of realism across a spectrum of concerns. And that really sort of set the tone for thinking about, some of the tools that I would ultimately come to work on and build here, including ghosts, right, which I'm sure we'll talk about.
So that shows you from the value of the team. Different normally when people would say they want to do cybersecurity, they would say, "Oh, you need to have cybersecurity experience," or someone would say, "Oh, they're not a good candidate to work with our team because they don't have cybersecurity experience." But in the case that having all kinds of different people, software developers, engineers, planners, different skill sets are very important to our team.
Yeah, so obviously the cliche is train as you fight, right? But just like the military, the thing that they want to accomplish in that is a sort of muscle memory, right? That has value in real life situations that might occur, and so like we focus on that, and part of that is to identify gameisms within training or exercise, and whether it's a system that they don't use in their real operations, or it's a configuration that they would never see that sort of allows things to happen in the environment that they would typically not have to deal with. I think that's a big part of it as well.
So it kind of brings us to the first early efforts from our team was the development of ghosts and the need to have what the Ghost product provides. You want to talk about Ghost briefly?
Yeah, so at that time there were, I think CERT had a long history of effort in simulating users prior to even my arriving here. But some of the more complex things that we wanted to do weren't available out of the box. There were lots of sort of competing products in that space, both open source and commercial products that weren't quite what we needed. And what we needed specifically is that teams today are so they're so good at what they do. They expect to say they see something on the network that they want to investigate. They would sort of track that back to host-based logs to correlate, oh, this event happened and therefore that's why we're seeing this traffic. But even to go back and look for artifacts on the network that would, taking those three things to account, triangulate what exactly occurred. And so none of the tools that we had seen before sort of offered that kind of realism. And so the sort of initial challenge to me was, hey, if we wanted to replicate someone doing something on the computer, we want it to look like it would look if you looked over my shoulder and I was doing it myself. So, no sort of spoofing activity that looks like a user, fired up a Outlook and opened some email message and ran an attachment they shouldn't have. We want you to actually do that. And, like I said, that was very different than anything I had worked on before. But that seemed like the most realistic way to simulate that sort of behavior. And the challenge of that just sort of kept eating at me. And I just had to start tinkering around with how would you build such a system to do that.
So Dustin, you raise so the delivery of the Ghost product adds a lot of flexibility to the cyber range. And say in the context of that is that we talk about training as you fight, realism in a cyber range. There's lots of different levels to that. And so take, for example, that if a particular Army unit was used to using Cisco routers or products from McAfee or specific vendors, we can provide those services within our cyber range. And so they can be there. But the problem exists that you have to have real user activity, realistic network activity for it to all make sense. Because otherwise, if you just deploy a bunch of Cisco routers or Microsoft servers, you have everything sitting there doing nothing. You have to bring that to life. You have to energize that somehow. And that's where Ghost really fits in, is where we can deploy hundreds of instances of Ghosts and really, not and we say simulate, it's not really simulation. Ghost is actually playing the role, that NPC is that user creating network traffic, browsing, web browsing traffic, file system access, Active Directory logins, file share access, and things like that. So it's bringing those different parts of realism together, which are really critical from the participant perspective to make them feel comfortable and believe that things are very realistic.
The team and probably you in particular are really good at pushing on that. And so if the baseline was to simulate, activity that someone might be doing on a computer, that quickly became a series of activities, right? So the user does this and that spawns them doing something else in the future. And like you said, being able to link activity from maybe what they're doing on their workstation to things that they do on other machines sort of quickly became the ask. And I think that's critical, because that's what you see the people that we want to simulate doing on the actual ranges. And I think you brought up a good point about simulate, right? Because we pretty quickly moved away from that term as well, because these are characters in a scenario that we're trying to play out, and they actually have a role that they're trying to fulfill, activities that they need to go and do in order to sort of promote that realism within that exercise. And that actually sort of bought into this whole idea. When we structure a scenario, it's almost like, setting up a complex playbook for a series that's going to run multiple years on a TV network, right? Because our exercise season can be very long, if we portray someone as insider threat early on in the exercise, we want all that stuff to stay the same throughout that season, so we can refer back to that particular person and the other non-player characters around them that they may have affected, right, in some way, shape, or form.
So I think that we had a lot of success with Ghost being able to provide those NPCs in a range. But what we did find by watching our players, our participants in our cyber range, was that some of the better players would find ways to take advantage, per se, gameisms of the NPC generators and NPC traffic generators and in the Ghost system to try to put them at an advantage, where they could see that certain browser user agents were used by the NPCs. And so if they found anything different from that, then that could lead them to maybe detecting malware quicker on their network, or watch some of the Army teams would even keep master lists of all the sites being accessed. And as soon as some malware site, which was not part of the normal NPC browsing sites, was accessed, they knew they could track on that pretty quickly to put them at an advantage within that exercise. So we were always looking for ways to improve ghosts, and adding the ML piece to ghosts was one of the first steps to improving that realism, such that the user, it was even harder for that participant to use those gamisms to their advantage and make the environment even more realistic. So, Dustin, you want to talk about that aspect of ghosts?
I think that's a funny story, because we were using ghosts to create all of these NPCs that blue teams would defend. And we pretty quickly asked the question, could we use ghosts to do different sorts of activities from the red team side? And, we do all sorts of different kinds of training within our directorate. And some of those are on demand. And those are usually targeting a very specific skill or tool that you want to get better at. And I thought, it would be really interesting to try to build ghosts as a thinking adversary for more advanced on-demand exercises. And I pretty quickly came to the realization that's a really hard nut to crack. And I was sort of disappointed, because there was no amount of resources that our team was going to have to build that sort of piece of software that would actually be realistic. And the problem with that is because, based on our experience in red teaming, you have to be very adaptable to whatever the blue team responds. And we just don't have the resources to build all those possible responses to responses. But one day you said to me, if you could just clean up the browsing patterns so that it wasn't so predictable, that would be a huge win, because of all the problems that you just stated, right? It's really easy to sort of spot random computer-generated behavior, because that's not really what teams would see in their real-world operations. The user agent string is a great example as well. And so, again, it was a sort of challenge that got me to thinking about how we might do that. Of course, technologies like machine learning and buzzwords like AI come up pretty often. And so we sort of, as a team, talked about how could we do some good in this space in a way that other teams could look at it and say, here's a very sort of simple, it's not a simple problem, I shouldn't say that. Here's a simple solution to a pretty hard problem that you can do yourself on your own hardware. You can certainly do it in the cloud, and we can talk about that as well. But I thought it was a really interesting way that project came to light, and how we sort of decided to approach it.
Yeah, I think that we were a little bit naive in terms of our ability to do thinking adversary easily, or how to use ML to create these the idea of a persona with an NPC. We thought, well, there's lots of efforts out there from a cloud perspective, using different vendors, different toolkits, and we really felt that we could probably accomplish that pretty quickly. But I think we hit a number of roadblocks with that. But I think ultimately, and I'd like to have you talk more about this, because this was a lot of your effort, was the path of some of the initial paths, some initial concepts of how we kind of identified NPCs in terms of having personas, having identities, some of the different things we looked at that actually failed at first, and then the work that you did to actually implement it in Ghost.
Yeah, so within our exercise network, there's lots of different enclaves, right? There's operations people, there's MPs, there's the med unit, there's logistics, and all of those different characters do different things by virtue of the role that they play. And so we would always have a sort of different list of activities that those users would do in comparison to one another. And the talk around, well, how can we personalize browsing patterns? We sort of have to we have to create more of a persona for that user, and that was a sort of formalization of those groups that we had we would sort of manage before, like I said, logistics versus operations. So we formalized that and we said, hey, the persona for this particular NPC is they work in operations. And so their concern is operational sorts of activities. And so if you think about, well, an agent is going to sit down and perform some list of activities. They would have a preference based on their persona to do the things that align with their job, right? And so we simply came up with a key value list of activities, which turns out to be preferences, right? And we assign those to given personas. So a persona is sort of a master bucket of all these preferences. And so people in operations have preferences to use these particular file shares versus some other, these particular printers versus some other, these particular websites and applications. Typically we use web applications, right? But they use these web applications to manage their operations day-to-day function, or versus a different list that logistics might use, right? And you can sort of imagine how that plays out in large organizations. Different people are doing different things, and this sort of approach just aims to replicate that.
Yeah, I think that it's a great first step in terms of making ghosts and NPCs more realistic. What challenges did you face from an implementation perspective?
So we have these preferences, right? And we can use those to make different decisions. So I have a strong preference to do this, or a weak preference to not do that. But it was sort of hard to figure out which model would best sort of implement that and make future predictions that were aligned with those preferences. And I remember we were looking at different technologies available on the different cloud providers, right? And one of the really early suggestions that you made was, hey, the next site that I'm going to browse is not unlike thinking about the list of sites that that I can choose from is not that different from a site like Amazon recommending the next product for me, right? Based on what I've done in the past, you're more likely to like or enjoy this smaller list of things that align with that. And so I think we had done some initial testing with different systems that provide that recommendation, and it turned out, this was our sort of first step into this area, and so we were spending a lot of time refining that model. Part of the problem is you don't want it to get too tightly aligned to a preference, because then all you're doing are the things that, it's more like an if statement. And we didn't want it to be like that, because human beings sort of randomly go to websites here and there out of curiosity or interest or whatever, right? And we wanted to be able to replicate that. And so we were spending a lot of time, which ultimately in the cloud, you can talk more to this, that winds up being more money, right? And we were looking very quickly for cheap ways or I should say more cost-effective ways of doing those sorts of tests, because we were doing lots of tests and trying to figure out the best way to approach the problem.
Yeah, I think we went in early on and thought that, well, the cloud providers the ML services that they provided could really boost what we were trying to do. And I think that we were very surprised upon two things: surprised at how expensive the cloud bill was for the first 6 months, but two, how much it really didn't help us that much, and how we really had to do kind of a grassroots, customized design internally to that we felt was compatible with what we were trying to do.
Yeah, for sure. I think that we spent a lot of time getting data into and back out of a format that they expected to use, as opposed to just building our model locally and sort of playing with what we already had. And that turned out to be much more effective. It turned out to be actually faster to run those tests. And you can see some of those results in the paper that came out of that. But we ran a lot of different tests, and we were able to do that, I think, in part because we just did it on our own hardware.
So it starts to raise a lot of questions like, okay, so how do you validate that success of that persona, being able to preference and align, and how did you create, how did you start and create those personas in the first place? Like, how is someone a sports persona mixed with a news persona, things like that?
I thought that those were just good. Those are just arbitrary choices for the paper's purpose, right? Because those are the sorts of examples that I think most people can visualize. Obviously, it extends to any NPC that you want to replicate, and I think probably the easiest way to think about those is what role is that NPC playing, and what activities do they do in that role for their daily operations. And so, again, I think any reasonably sized network would have different types of people doing different types of things, and those personas are an easy way to break that out. So you can move your operations people into a particular persona, and then still randomize the preferences that they have for that persona. So you get that differentiation between person A and person B on the range. But that would be very different from a person, say, in logistics that's doing different sorts of activities using different kinds of applications and browsing different kinds of websites.
So I think, stepping back from it, I think it's interesting to also point out here the passion you have for this particular problem. When you first started SEI, you kind of came in as, say, I'm a developer, software engineer, and now you're faced with very interesting problems. And I think that's one of the attractions and we've seen this some of our data science folks that we brought on recently, is that, in private sector, they're busy doing tasks related to, making money for a particular company, and boosting the bottom line. Whereas in your case, you're in our teams faced with very interesting problems. Like, okay, how do we make this more realistic from a NPC perspective? It's not something that it's not something that you're going to find out there as a typical problem that needs to be solved in most places. And so having an interest and a passion and trying to just incrementally make things better, and sometimes making bigger leaps, is one of the attractions of working at SEI.
Well, I totally agree. And some of those problems, we find on our own because we identify, hey, here's an area that could be better for training and exercise. It came up in a after action report or something like that through the customer. But there are other ones where the customer comes directly to us and says, hey, here's a really hard problem. Do you or the SEI have any publications that can assist us in this particular area that we're struggling with, or we're trying to get better at, and we actually have some recent examples of that if you want to talk about them.
Yeah, one of the key aspects here is considering SEI as an FFRDC. We're here for technology transfer out to others. We're here to incrementally make things better, improve things, and publish that and make that resource available so others can take it and use it and make it better for their own uses.
Yeah, I love that we were able to open source Ghosts and that entire ecosystem. There's a couple of other plugins or applications that assist in creating the NPCs using publicly available information. We try to create NPCs sort of randomly, but that are realistic for different kinds of purposes that you might be interested in. Like when you generate a new range, when we generated a new range for this season of exercises, we have a tool called Animator that does that. We have this tool that we're specifically talking about called Spectre that increases the realism of the browsing patterns for NPCs that you already have deployed to a range. And there'll probably be other things that come up in that Ghost ecosystem that we'll be able to open source. I know we have some some very specific tools that help us do different red team activities. You have a tool that helps diversify IP addresses for that traffic coming in to a blue team network that they're defending. So I always get really excited about that, because the range of people that are then able to take advantage of those tools for their own training and exercise scenarios just grows exponentially. And we've seen, we've been contacted by people, all over the world, both in the United States for the Guard and Reserve units that want to train and exercise on their own terms. From the Five Eyes, we're sort of big in Belgium, but I just think that's a great opportunity, and I'm glad that the SEI and our customers and the Army enable us to do that.
Yeah, I would agree. It's always interesting to see who's interested in some of our essentially ecosystem of products that surround ghosts and supplement those realism activities within our cyber ranges. It's very rewarding too to see other people, using what we've created or the documents that we've published. Like you originally discussed the reactor framework. That's the realism framework we published a number of years ago. There's actually a follow-up ghost white paper, technical publication from SEI. There's a publication for actually implementing realistic cyber ranges in very much more detail. In this recent paper from you about NPCs and the ML enhancements for that.
Yeah.
So I can say that in addition, though, Ghost will always Ghost and NPC and increase NPC browser activity for realism. Actually, we find other uses for it as well within our ranges. For example, we're doing some research now on detecting network beacons. And so we're interested in having ghosts generate very, very realistic traffic such that we can produce data sets that can be used to validate our beacon detection models. So our data science folks can say, hey, I'd like to use these methodologies to detect beacons, new things that they're working on, but they really need to have some data set to confirm there are different technologies or different approaches for detecting beacons. And so using ghosts to generate traffic to essentially hide the beacons that would exist within that traffic, the network traffic that the beacon detectors are trying to pick up is just so critical.
I can't believe I didn't mention that, but yeah, Ghosts has been used by other researchers at the SEI, Ching Han and some others, to generate that realistic network traffic, and it's awesome to support them. It just occurred to me, do you want to talk a little bit more about what beacons are, just so people are clear on what you mean by beacon detection?
So essentially, some of the teams that we've worked with previously, some of our customers have come to us and said, hey, we have a problem detecting we have a problem essentially detecting malware command and control servers that are essentially what we would call sneaky, in the sense that they don't communicate very often. So you may have some sort of advanced persistent threat which may able to gain a foothold within your network and only communicates back to its command and control server, say once or twice a day or once a week. And those sorts of network activity are really, really hard to detect, especially on larger networks that have just millions and millions of network traffic events. So we're trying to develop fast methodologies to be able to detect that adversary within your network. So the concept of a beacon is that call back to the command and control server by the adversary.
Can you talk about some of the techniques that we've been looking at for doing that in a sort of new and novel way?
So there's been a lot of different efforts from CERT and different organizations to do beacon detection. And starting last fall, the summer of 2021, fall 2021, we decided to maybe take a more original, more unique approach to beacon detection, where we looked at some machine learning techniques from related to unsupervised machine learning related to clustering. So we applied some different clustering algorithms to actually detecting network beacons, and we found actually some pretty good success with that early on, and have persisted in that research over the past year. But you've been heavily involved in that as well. Do you want to comment on it from a clustering perspective in terms of those algorithms?
So I think the first thing we looked at was k-means. And obviously, if your beacon is checking in every 5 minutes consistently, k-means will catch that. But if there's jitter, which I think most systems we have been looking at try to do, then k-means will give you a lot of clusters that necessarily don't match up. And so we started looking at ways to sort of pick out the outliers. But we found this DB scan algorithm was sort of an improved k-means, where it would throw those outliers out by default. And so we were able to identify different clusters. There's still some challenges with that. Part of it is, how far to zoom in or out on a time scale. So, like you said, you can have beacons that check in every 5 minutes, every 5 days. And so you sort of have to adjust the lens for how you're looking at that data to match that. So we're still doing some research in that area. One of the things that a recently joined team member is making a big difference in is making that algorithm faster. So if you're adjusting the lens, obviously you have to rerun those algorithms on that different set of data that you're the time span that you're covering. And he's done a lot of work. Sean Huff has done a lot of work in speeding that up and making it as close to real time as possible. Is it real time? No, not quite yet. But our thought is that, wow, what a tool it would be to be able to provide teams with something that's watching for those beacons continuously. And when it finds something with a high likelihood of this, this is a high likelihood of beaconing activity, it could throw an alert and they could go and investigate further. There's a lot of tools out there that have chipped away at this problem. But one of the things I think you always want to be mindful of is that if you throw too many alerts, then they sort of become useless, because SOC teams don't have time to go and investigate every single one that you throw if you're throwing hundreds of them a day. And so we were trying to stick to very high likelihood examples of beaconing that other tools wouldn't catch, right? Like you were very quick to say, you should probably ignore anything that's talking a lot, because that would just come up in a top talker report, and it eventually get investigated and whitelisted or blacklisted. But those other ones that are longer but have a high likelihood, that's something that security teams would want to take a look at.
Yeah, the one concept that we always tell the data science folks who are doing that, helping us with this effort, is we're trying to find the most interesting things to look at, because you may give a security analyst at the SOC 100 things to look at, but if we can help them look at the most interesting things and really narrow that down to just a few items, a few IP addresses, or a few websites to take a look at, that really helps a lot from finding advanced persistent threats and finding adversaries in your network. But going back to the original the concept of this podcast, which is Ghost has found we found another reason to use Ghost, and the realistic and the ML pieces of Ghost are really beneficial to helping us generate these data sets from a data science perspective. if you were to say, oh, I want to test my new beacon algorithm, well, good luck going out there on the internet somewhere and finding a data set that has, source IP diversity from hundreds of different source IPs going to thousands of destination websites, all doing realistic browsing, as well as mixing in Active Directory traffic and file server traffic and other internal SharePoint traffic, things like that, and find that data so you can test your beacon algorithm is really hard to do. It's not really publicly available out there, whereas we can generate those data sets along provided by the ghost activities is just super valuable to us.
It's all just layers of realism, right? If that wouldn't be possible if we didn't have a sort of best-in-class range that allows us to run ghosts on it and have that sort of diversity. But yeah, I agree, and that's actually sort of one of the things we never talk about, having that ability to run those sorts of experiments on a range like that, with that kind of diversity of IPs and such.
But, yeah, and then the benefit to the data science folks is that if they want a change to the data set, or they want more beacons or less beacons, we can, in our range, we can generate more traffic with the aid of ghosts and generate that on demand. If they want a week's worth of data, days worth of data, a month's worth of data, we can refine that and get that to them to continue their research.
So what do we do next? I mean, not to put you on the spot, but what should we build next? What's interesting?
Yeah, that's always the big question. It's I think that we're just going to continue to refine the idea of a more realistic ghosts and having ghosts do more things, right? Can it be a chat? Can it be chatting to a team server? Is it accessing SharePoint? Is it uploading, downloading content? And some of those features are already available. Just continual refinement of that work, I think, in terms of ghosts, and just find other aspects on the range to make it more and more realistic. What are your perspectives on next steps for some of our efforts?
I can't disagree with any of those. One of the hard things still is if you wanted to script out very specific commands for a group to do, that can be time consuming and sort of tedious. I don't know if the answer is to make the scripting language for doing that easier and faster to use, or to build some tool that automates the creation of those user activity scripts or whatever we want to call them. So that's always been a challenge. I think we could probably make progress in that area. I agree, other tools, being able to automate other tools. So, some of those are difficult, though, right? Because by sort of definition, that you don't want them to be automated because bad people on the internet use them for nefarious purposes. But I agree, like chatting is a big part of network activity that we should be able to support. And it's probably some other things around that ecosystem, like you said, downloading docs from SharePoint or updating a wiki page or something like that. Yeah.
And I think that so ultimately that goes back to the concept of the original blog and this paper on NPCs and ML, which is having that ML piece and the persona piece and the customization piece to make these NPCs even more realistic is really the kind of the big bundle of bringing all these things together. Go ahead.
Any other application of ML to make that NPC make more realistic decisions, I would definitely be interested in that.
So Dustin, as usual, we could probably talk for hours about these areas, and you can see that like I said before, the passion you have for this for pushing this forward. It's not something that you stop thinking about it at 5 o'clock. You're thinking about it and trying, because you find it is an interesting problem to solve, and it's good that it really aligns with problems that are very critical to the defense of the United States from a cybersecurity perspective going forward. Do you have any final closing comments?
Yes, I think we covered a lot of things, good stuff. I actually can't stop thinking of it because I'm still a graduate student at Carnegie Mellon's School of Philosophy. There's lots of interesting courses on decision theory, game theory, and so some of the concepts that made it into ghosts came directly out of some of the studies I've done there. But our team has been great in sort of augmenting the things that I'm able to do. Right, you're more of a systems network person, and I'm a software person. Put us together, and that works really well. And I think our team really does a good job of that diversification of skills. I suspect that cybersecurity needs more of that, right? Because the challenges that we see, a lot of the issues that we try to replicate in scenarios are not always technical problems, right? They're process problems or people problems or social issues. And so I think many of the things that organizations are struggling with today are not necessarily just tech problems. And so maybe we need some other viewpoints on how to solve some of those issues. And I hope that Ghosts is someday able to replicate some of those problems, right? Because you can coordinate activity between different agents, and agents can tell each other different bits of information, and that could obviously influence the decisions that they make and update their preferences and all of that. So we'll just keep evolving it until it starts doing things in exercises that we can't really account for, and we have to dial it back a little bit.
Yeah, that'd be pretty exciting to see that. A little scary, I guess, too. But I 100% agree that not all these cyber issues can be solved with just straight cyber people. There's a lot of different types of people that come to SEI that have lots of different skill sets that are great fits for helping us solve these sorts of cyber challenges that are so critical. So we'll wrap up here. A quick note to our audience. A transcript will include links to all the resources mentioned in this podcast. So we talked a lot about some white papers, some blogs, and actually some open source software that exists out there already, because Ghost is open sourced. So those will all be included as part of the transcript. Dustin, really appreciate you talking with us today. It's been very, very great conversation. I'm sure we could talk for a lot longer. So we'll wrap up here. And finally, a reminder to our audience that our podcasts are available on SoundCloud, Stitcher, Apple Podcasts, and Google Podcasts, as well as SEI's YouTube channel. If you like what you see and hear today, give us a thumbs up. We'd really appreciate it. Thanks again, everyone, for joining us, and we'll see you soon.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.